Hello, internets
Greetings
and salutations unto thee.
unto all.
Uh-huh. So, let's see. Today, we're going to finish the lobby using WebSockets.
What is a WebSocket?
Hmm. So, are you on the stream?
Not yet.
Oh, okay. Join up the stream.
Okay.
I'll start explaining what a WebSocket is.
Okay. One moment. Okay. Oh wait, I was a part of it. Okay, I'm here.
Yeah?
I was a part of it. Okay, I'm here. Oh wait, I was a part of it. Okay, I'm here.
There's feedback.
Oops, sorry.
Okay. Let's make a drawing. Here is a drawing. See the drawing?
I see the drawing.
All right. All right, so WebSocket. Okay. So normally, let's get a person. I need a face. Here's a face. Okay, so here's a user. And I need another shape. Let's put the web server. Let's make the web server a square, rounded square. Okay, so here is our server. So there's our server, yeah? So normally, when you want to do something, the user makes a request to the server, and then the server gives you back a response. Let's try that again. Oh, it's okay. Yeah, it's not it keeps connecting the dots. It's not exactly what I want. But yeah, so that's a normal web session, right? So user makes a request to the server, server sends back a response. Now, a WebSocket is for a different kind of interaction. Supposing, like we do in our video game, that we have multiple users. So here is the multiple users. Here we go. Okay, so this is our setup now. And what we want is this interaction. We want it to be so that when this user sends a message to the server, we want the server to get that data and send back a response to this user, and send a response to this user, and send a response to this user, and send a response to this user.
Oh.
Does that sort of make sense? Uh-oh, you're frozen. Uh-oh. Still around?
Oh my god.
Are you back? Yeah, I think you're back. No, you're frozen again.
Lost your network connection.
Are you back? I think you're back now, sort of. Oh. Are you back? I think you're back.
Yeah, I'm back.
Okay, great. So did you catch all that?
Not at all.
Not at all. Okay, let's try again.
I heard. Okay, you're about to start using the arrows with the multiple users.
Okay, let's go again. So this user sends a message to the server. Oh, one sec. I need an arrow. So this user sends a message to the server. Yeah? Then the server, so that message might be, like if you're playing poker, it might be fold or bet or something, right?
Mm-hmm.
So after this user has played their turn, the server is going to send back a response with the updated state. But it's not enough to send it to that user. They also have to send it to this user, and they also send it to this user, and they also have to send it to this user.
Mm-hmm.
Make sense?
Yeah.
So if you recall, when we were making the lobby, when you join the lobby, right now, you have to refresh the page to see all the users that have joined. That's because we only have the user sends a message to the server and the server responds. So let me show you the way it works right now. The way it currently works. So let's say there's no users playing the game yet, right? But then this user says, okay, I want to play now. So he says, join game. And the server says, welcome to the game. Here are all the users in the game right now, which right now is just him. Then this guy says, okay, join game. And the server says, okay, welcome to the game. Here is the users are you and this other person over here. But this person doesn't get a message saying that this guy joined. Hey, Rickles, welcome to the stream.
Hello.
Hello. I am currently in the process of explaining the purpose of WebSockets.
Yes, I was listening.
All right. Sounds good. So, okay, so that's two users. Now the third user says join game, right? And then the server responds and says welcome to the game. And again, doesn't send any update messages to the other players. And so these players only see themselves, and this one sees the other two. Until these guys say, refresh the page, please, give me an update, like this, only then do they get an update. So that's when you have to refresh the page to see the new people who joined. Make sense?
Mm-hmm.
So WebSockets allows the server to send a message without the user asking for any data. Right? That's the key. So this user joins, and the server says welcome to the game. This user says join, the server says welcome to the game, and sends an update to this user. Right?
Mm-hmm.
Now this user joins, and the server says welcome to the game, and hello, another person has joined, let them know, and hello, another person has joined, let them know. Make sense?
Mm-hmm.
So this is what we're doing today. We're going to get all this working. So how does it work?
It would be too complicated.
It sounds complicated, huh?
Well, it sounds complicated to get it working.
It is. It is complicated. It's not simple. I'm not going to lie. But it's not impossible. And I will explain things as we go. So here is how this works. The user joins and says, I want to create a WebSocket so that you can send me updates. And the server says, sure, you got yourself a WebSocket. Then the next user comes along and says the same thing. Give me a WebSocket. And then the server says, okay, welcome, you have a WebSocket. And then the third does the same, and then the fourth. Okay? So far, so good?
Mm-hmm.
Uh-oh.
Oh my goodness.
Yeah, there we go. So now all the lines are following. Cool. So now on the server side, each of the person's connections is part of it has its own context. Okay, and in the code, it looks like this right here. So we have this game status, which is a WebSocket, and then when the user connects, we accept the connection here, and then we have this loop that forever goes, forever. We did this last time. We loop forever, and we send updates with the game state to the user. Right? This is what's happening. What we need to change is we need to make it so that we essentially send out an update to all the players of this current game whenever a change occurs. So we need a way to know when a change occurs, right? So here's how we're going to do it. Right now, a change occurs when specific things happen in the game. Things like fold, things like bet, but we haven't even gotten that far yet. Right now, the only change that matters, because we're only building a lobby, is that you add a player. Okay? So when you add a player, we need to let all the other players know that it's time for them to get an update and give them that update. Right? Going back to our story here, so we have these connections, right? Now that we have the connections, I need some color. How do I change the color?
Maybe the arrow. Oh no.
Oops. Wrong bouton. Format.
I wonder if we should send. I'm gonna send our link to our D&D group because they wanted to know what we were doing.
Oh yeah, do it. Send them the link. Oh, hold on. I think I might be able to change the color here. Line color. Let's make it red. Beautiful. I got a red one. Oh, all of them are red now too. Beautiful. Okay. So the idea now is all of these guys dial in and say, give me a connection. Okay? And so that is happening right here on line 95. Right? Give me a connection. And what we need to do is the server needs to keep track of those connections. Then, when we add someone to the game, when we say add player, either of these add players, when we do that, we need to then somehow allow this function to continue for all four, or all of the like in our example, we have 4 players. We need this loop to continue for each of these people so that they can get a message, right? Because this is the server side sending messages to the users. Make sense?
Yeah.
This line here is where we send the game status update to the user. And right now it's set up so that it just sends a message every second. We don't want that because that's just going to be too many messages over and over and over again. What we want instead is a message only when a change occurs. Make sense?
Yeah.
Yeah. So the question is, how do we do that? And I was trying to figure it out last week during the stream. And because I hadn't thought it through yet, I wasted a bunch of time. This time I've done my research, so I know how to do it. So I'm going to show you guys how to do it. There is a thing called an event in Python. And what it allows us to do is when one execution context is doing something, we can trigger other execution contexts to resume using this. Let me show you. This is the example here. So you create this thing called an event, and then blah, blah, blah. Meanwhile, after you create this event, you create this other task. So think of this other task as all the users currently waiting for updates, right? So waiting for an update, right? And so then they say, okay, wait for the update. And so all the users are now waiting on their own event, right? So we create a separate event for every user that is waiting. Then, when we're ready to let them know that it's time to do something, we take their event and then we call set on it. We say, the event is ready. Go ahead and process the event, right? And then these guys will then send their messages to the players, and then they'll go back to the loop and wait again. Wait for the next event. Okay? So here's the idea. We want to create an event, and then when the event gets set, we want to send the JSON, right? And then once we send the JSON, we want to clear the event and then wait for the event again. So every time we get an event, and in this case, the event is something has changed, send an update. Make sense?
Mhm.
Okay. So that's what we're doing. Let's look at the drawing again. So these guys connect. The server creates an event object and associates it with this connection. And every user who does that, we create this event, and then we store it in the game as a big list of all of the different events that need to be notified when a change occurs. Then, when any one of these users sends a message to the server, oh, it didn't change to red. Hold on, let's make it red. Yeah, there we go. When any user sends a message to the server will then set the event on every one of the users in this game, which will trigger a message going back to every user. Not just those three, actually. It will even trigger one back to the user who set the event, right? And then on the server side, we will then clear the event so that the next person to come along can trigger the same set of events again. So for example, if now this user sends an event this way, need a different color. Let's use blue. If this user now sends an event, the server will then respond by sending back events to everybody this way. You with me?
Yeah.
Yeah. So I'm going to write the code for this. You guys don't have to worry about it. I'll take care of this particular one. We're going to get this done in 10 to 15 minutes, test it together, and then we'll start our JavaScript tutorial, which will be much simpler than what we're currently working on. This is some pretty advanced topics, I would say.
Yeah, it seems advanced.
Seems advanced, huh?
Because it's all about updating and all these other elements that are unusual, I guess.
Yeah, it's a little unusual, but it's not unlike a chat app. We should build a chat app at some point, which is a simplified version of what we're currently trying to build.
That's true because you're always updating. I guess it's the same thing, but
Yes.
like with messages and stuff.
Exactly. So,
Cool.
so let's do this. So when someone creates a connection, that's when we need our event object, okay? So we're going to say event is equal to asyncio dot event, okay? So here is our event object. You guys with me here? This is the thing that we're going to wait on. We only need to make one of them. That's why we don't put it in the loop. Okay? And once we enter the loop, we want to... we basically want to do this. We want to say... So here's the idea that I have. We'll enter the loop, and no matter what, we'll always send one status update at the beginning. Regardless of, we're not going to wait for a change to occur. We're going to send an update immediately, right? And then we will wait for the event to be set. So we'll say await event dot, I think we just say await event.
Oh my God, I just understood what await meant. It's literally when you wait for something.
Yeah. You just await. We should go through some of them so you can see. This one here, await ws.accept, this is saying wait for someone to connect. Right?
Like the accept is like
accepting a connection.
accepting a connection.
Yeah.
Ooh.
And then this one here is send a response and wait for it to be sent. So we don't do anything until the message is sent. Here we're awaiting the event. This one here is what we had before. This is saying wait for 1 second. So sleep means go to sleep for 1 second, and wait for the thing to wake back up. That's what this one here is doing. So we don't need the sleep anymore. So we're going to delete that.
Yeah, what's going to sleep exactly?
So in this code, if you recall from before, it used to do a timer, and it would send a message every second.
Mhm.
And then you'd see 1 second passed, 2 second passed, 3 second passed, 4 seconds passed, right? So without the await, the thing would just run as fast as the computer can go, and it would just send message, like as many messages as it could possibly can do. The await allows it to say pause for 1 second. In this case here, go to sleep, and then wake up, and then send another message, then go back to sleep, then await for that sleep to finish, which is 1 second long, and then it wakes up and send another message. Make sense?
Yeah,
Yeah.
that's cool.
So let's see where we're at. We're using these synchronization primitives, and this is how you do it. Await event.wait. So that's what I'm going to do. Await event.wait, like this. And immediately after this event is set, it's going to be set by the central version of the server. Okay? Let's go over the picture again. These guys are all waiting on their connection, server side. Let me draw it again. These guys, when they connect, they're now awaiting. They're awaiting a response from the server. Yeah, they've all connected. They're all waiting. The wait, of course, is on the server side. Nothing is on the client side. All the waiting is happening over here. But each one of them is happening in their own call to game status, right? Because like every user is calling game status. So every single one of them is running in their own loop, right? Each user is in the loop independently of one another. So that's where we're at, right? And what we need to do now is, so each one of these guys, each one of the users is awaiting, right? So what we need is when a change occurs, and the change that we're talking about is add player. When somebody calls add player, we need the add player to go and talk to every event and say, every event here, you're notified to stop waiting for a sec, to go and do one more process, and then wait again. Make sense? Yeah? Okay. So once the event is set, though, we need to clear it. So we will go here and we say event.clear. And let's see what the synchronization primitives are for it. So there's event.set and there's event.clear. And you'll see in the documentation that there is this word called coroutine. Don't worry too much about it, but if something says coroutine, it means you have to await it. That's what it means. One day we'll go much deeper into await and stuff, but not today. Okay, it's not that important. You just need to, just at the most surface level, if something says coroutine, you need to await it. So we're awaiting the event.wait, and then we do event.clear. The reason why we do event.clear here is because someone else is going to be doing event.set for us. Right?
Mm-hmm.
Okay, so let's do this. We now need to put all the events into one place so that that other thing can set all the events. Okay? So that will live in our game object. So I'm going to just come down here. I'm going to say self dot, let's call it just events. And events is just going to be a list. And specifically, it is a list of asyncio dot event objects. This notation that we're using here allows us to tell Python what these things are, so that when we're working in the editor, it helps us a lot more. You don't need it. You don't strictly need it. This is only to help us as we write our code. This bit here. I'll teach you guys more about types later too. Don't worry. So this events is going to store all of our events for us. Right?
Mm-hmm.
Okay, good. Now, what we need to do is once we create the event, we need to put our event into the game object to hold on to it for us. So what we're going to basically say is game dot events, right? We're basically putting it here. Game.events.append our event. Okay? Cool. We also need to clean up after ourselves, but we'll clean up after ourselves later. So let me show you what that means. To do is remove the event from the game when the user disconnects. Okay? Otherwise, we will continue to try and send messages to that user even if they're no longer there. Make sense?
Mm-hmm.
Yeah. So we'll just have that there as a to-do. Next, now that we've got this, so this is going to ensure that there's a bunch of events in the game, right, that we can notify on. The next thing to do is when a player joins, we need to notify all of them. So I think that you guys will be able to write this bit of code. So I'm gonna let you do this next bit. So all of our events are here. These events is a list of the event objects. Whenever a user connects, we're going to be adding that event to this event list. Okay? What we need to do now is when a player joins, we need to loop through the events and set them. So if you recall, we're talking about this set. Okay, this will set the event, and it will cause all of the people waiting for updates to be awakened, and they'll get an update. Right? All right.
I see.
Yeah, you see? Okay. Satch, should I call on you for this one?
Okay.
Okay. So what you're going to write now is some code to loop over the events and call set on every single event. And that will reawaken everybody waiting for messages so that they get an update. So, new line here. I put my cursor where you need to be.
Live share.
Click.
Okay.
Click.
Mm-hmm. Yep. New line. Okay, so we're writing a for loop. So we're going to for
FOUR.
FOR. Yep. So we're for looping over events. So we're going to say for event, space for event, in, and now we're looping over the set of events that are in this events variable. So type that out. Okay, colon, and then new line. Okay, so what this is doing is it's going through every entry in the events list, and event is each entry.
So do we have to write all the different events that would happen?
So we're sticking to just one event. The event that we're dealing with is just a change occurred, and let everybody know what the current status is.
Oh.
So we won't bother with different kind of events. We have one event that something changed, and we don't care what that was because we're just going to send the whole status block to every user. If we wanted to optimize it, we could, but I mean, this is what we can do is if we need to optimize it, we will. This is not a big deal. Like, I mean, poker doesn't have that many. If we were playing like a real-time strategy game where, you know, like things are moving all over the place, we may want to reduce how much data we're sending. But in this case here, like we're talking about one event every 5 to 10 seconds at most. That's nothing. That we can just send. We can just send the whole payload. So the next thing to do now is take that event and set it like this.
Event.set.
Yep.
I can write it now.
Yeah, it's you. It's all you.
Right, open brackets.
Mm-hmm. There you go. Okay. All right. Let's save that.
That was fun.
Yeah, I thought so. All right, let's give it a try, okay? So give me a sec. I'm going to join the poker game. And then I'm going to set up I'm going to call our WebSocket. And we'll see if when you guys join the game, if I get a notification. So let's put this over here. Sign in.
Do I have to save it or you saved it?
I just saved it, so you're good. And I'm going to host, create a game. Oops, I broke things. Sorry.
Don't break it. I can have it.
Cannot read properties of undefined. Yeah, I think I broke this. One sec, you guys. Let's fix it.
Let's fix the app.
Let's fix the app. Fix it up. Was my drawings useful? Did
I like them.
Okay, cool. I'm glad. Okay, so we broke I think I broke lobby. I was cleaning up the code and making things simpler. So I think I broke this part here. Lobby line 31. So players, game state, cannot read properties. Okay, let's go here. Console.log, game state. Let's see what I broke. Reload this page. Oh, it's empty. Why is the game state empty? So the game state is called here. Oh. Let's try again. Shad, create game. And then here's the game state. Oh yeah, there is no...
So the payload wasn't sent properly?
I'm trying to figure... Yeah, I'm not sure what I broke here. What has happened is this line here, game ID and game code, is correctly arriving here. Oh, hold on. Let me see if node... Yeah, so we're sending back. So this is working. Hold on, let me double check that it's working. I'm just going to put Sachi here.
That's me.
That's you. And then when we create game, we should see, oh, this is not where I think we are.
Oh, because it's not even showing Sachi.
Yeah, it's supposed to show Sach. Like if I did console log shad here, I would expect to see my name appear when I go here. Ooh. So, okay, so it's not here that's broken. It's something before here. And game state is empty. Okay. So the problem is happening earlier on. It's probably happening maybe in the... Is it the... Maybe it's happening in game. No, can't be game. Home. It might be happening in home. So here it's console logging payload. So if I put Sachi here, reload, shad. Okay. Still not printing Sach. One sec. Oh, that makes sense. This is not, this is for joining a game, not for hosting. Hosting is up here. So put, okay, so here's where, so this is where it's landing. And here's the payload. But then if game code so this is supposed to send you to the game ID. So I think it is doing this part, yeah? Okay, let's double check. Refresh. Shad. Okay, there's shad. So we know that part's working now.
Oh, nice.
Yeah, so this is where that's happening. And then it sends us to the lobby. And when it gets to the lobby is broken because the game state is empty. We make a call to API games/game ID, but it's not returning anything. So the problem actually, I think, is that I think the only thing we need to do here is say return if yeah, I see what the problem is. Okay. If players is not in the game state yet, then we can't do this map. So we need to not do this if there's no players yet. So let's see here. If not game state, this is a hack. So if or better yet, if this is undefined, basically. If this is undefined, then return. Return hello. Return the hello string. Okay. Yeah, we need to fix that. So, yeah.
Oh, did you just fix it?
Yeah, but it's a hack. So here's what's happened. I'll explain what happened. So when you initially come in here, we haven't loaded the game state yet. And so if we haven't loaded the game state, this bit here is not going to be not going to have a value. And so it's not going to be able to present the user with anything. So while it's loading, we need to actually put like a spinner on the screen. We need to say loading. Make sense?
Mm-hmm.
Yeah. So for now, I'll just have this little hack here where I think the smarter thing is actually to say null. And then if game state is null, then show this loading. That's the way we want to go. All right. Oh.
Your face is gone.
Yeah, why did it go away? Let's start over. That's what I want to do. I want to start over. Session storage dot auth. Delete. Reload. Sign in. Shad. Yeah, so that should clear the state. Create a game. Oh, I'm still broken.
Does it matter that there's 3 equal signs there? I know it's a small thing, but I've never seen 3.
Yeah. We'll cover that in our JavaScript tutorial. Don't worry.
They can go on forever like train tracks.
Yeah. Use user. I wonder why that only broke this time. 403. That's weird. Okay. It's funny because when this was undefined, it was fine. Or not. Now it's just broken all the time. Okay. We'll have to investigate why. Wait, hold on. What is 403? 403? Oh, it's forbidden. I'm forbidden.
What?
No. We've been forbidden.
I love it.
403 is forbidden. I see. Okay. So I'm apparently not allowed to access this sometimes? Interesting.
Maybe it's your hack. Your hacking was forbidden.
I don't know. Maybe. Copy
Just
link
hack it.
address. No, it's not forbidden when I go to it like that. It's just forbidden. Interesting. Oh, interesting. Okay, don't worry about it. Oops. Don't worry about it. It's not oh, now it's loading. This is so weird. Okay, we have a very weird issue that we're going to have to deal with.
Yeah, we got a moody poker game.
Yeah. We're going to need to do something about this. For now, though, you guys see the game code. Don't join just yet. I need to set up our WebSocket. So here's our WebSocket, WS Games. Okay. And so if you so let me show you here. In main, we're going WS Games, the game ID. So my game ID is this string up here. And I don't currently have any permissions on this. Anybody can talk to this right now. Okay, so I'm going to connect. All right, I'm connected. So let's just I want to walk you guys through what just happened, okay? Because we're going to have to do this on the client side as well. Hold on, I want to see your faces. One sec.
My face.
Yeah, let's put this there.
My face is awesome.
Indeed. Okay, so here, okay, so so right now I'm writing some code directly into the browser's console so that we can test things out, yeah? And the first thing we did is new WebSocket, and we're connecting to our endpoint that we just finished writing in Python, right? And then we have a bunch of things that will just print out messages as they come in. So here is the event, right? This is the message. This got sent to us on line 100, right? Send JSON, game to JSON. That's what this is. So we're seeing the players. We're seeing the game code. We're seeing the game ID. You got it? You with me? Now, I'm also connected here. So the moment you guys join the game, I will get an update based on the code we wrote. When you join, it's going to call add player. When you join the game, it's going to call add player. And when it calls add player, it's going to run the code you just wrote, Satch, which is going to loop through the events and set an event. And remember, I am waiting on an event right here. This is where my code is currently waiting. And the moment you set the event, it's going to continue here, clear the event, go back to the top of this loop, and then send me another update. All right, so do it. Join a game. The game code is UVCG. Aha! Did you see it happen?
Ah,
So there's
Wait, I
Shad.
wasn't there.
There's Shad, and there is Rich. Sorry, let me make this window slightly wider. There's Shad and there's Rich. See
so
the
now it's
update?
updating in the console first.
So yeah, so far we've only built this into the console. So it's not gonna update our players up here yet.
Yeah.
Ooh, Sachi. Or maybe it's
Sachi.
Sachai with that many E's.
Sachi.
So you get it? You with me? You feel me?
I feel ya.
Okay. All right. So there it is. Our server-side code is working, sending us update notifications. What we need to do now is connect to it from inside our client. And when we get the updates, update our status as well. Yeah? So you ready for this?
Mhm.
Okay.
Ready.
So check it out. So here we have all this stuff that retrieves the game information via API games game ID, right? This is what we did so far. Instead of this, instead of fetch, we're going to instead do what we did in the browser here. We're just going to create a socket that connects to the game ID, and then every time an update happens, we're going to do a thing to make a change. Make sense?
What is it?
What is what?
Can you say that again?
Okay, so here on line 13 in lobby, this bit of code here, starting from line 13, ending on line 19, is where we go and fetch some data from the server, right? And if you refresh the page, you will see the update. But we don't actually need that anymore, right? Because we're going to be using our new WebSocket, which just gets updates as changes occur. So instead of being a single one-off request, we're going to instead make a request and get updates as time passes. Make sense?
Okay, yeah.
Okay, so here's how we do it. How do we do it, actually? So first of all, we no longer need this. How do we do this, actually? says me. Let's go. So we're basically gonna say const ws equals. So we're basically doing this bit of code here. Yeah. So we create a WebSocket, and we're gonna have to do some stuff later. I'll fix it up on my own time. It's not important. But basically, we're making a connection to port 3000 WS games, and instead of this string here, we need the game ID. Right?
Mm-hmm.
Game ID.
Game ID.
Game ID. That's right. Next, we need to do the same thing. We need to say ws.onMessage. OnMessage. And then we have a onMessage equals a function that takes an event. And then the event object is this JSON stuff that we got here. So it's in this data. So event.data. And then we need to convert this. So if you look over here, right, in the console, data is a string. We need to convert this string into an object, which I will teach you all about when we start doing our JavaScript tutorial. But basically right now it's a string. We need to convert it into an object. How do I do that? I forget. But I mean, it's usually just like something like this. But let's quickly search. JavaScript string to JSON is JSON parse. Okay. So we're just going to say JSON.parse the event data. Okay. And when we get this data, we need to put the state. This is the state information. We need to put it into game state, right? If you recall, this bit of data here is the game state. So instead of doing all this stuff to set the game state, we can instead just wait for messages from our beautiful WebSocket, get the data out, and put it into the game state for us. So now we have here const game state. Let's just call it payload is equal to this, and we need to save the payload into game state. So we say set game state to payload. It actually looks very similar to the jazz down here. Now we will, right now our Python code doesn't require any authorization, but we do need to put that in soon, just not now. So instead I will just do this thing where I comment out all this jazz, like so. And theoretically, hey, it just worked, I think. Did it?
Wait a second.
That's...
This is good to be true.
It does seem a little bit too good to be true. One sec. But it could be too good to be... Hold on. One sec. Let's do this. I'm just going to put a console.log payload here. The purpose being I want to see... yeah, it actually... it is working.
Yeah, I see that array 3.
It is working. The only problem is that... oh yeah, it is working. Okay, let's test it out. So I want to restart our backend server. Okay, I'm restarting our backend server. And I am going to create a new game, host a game as shad, create game. Okay, y'all, I think it's working because like here we got the response from the WebSocket and it populated my name. So if you join, it should just appear. Yeah, Rich is there. How about you, Satch? Are you muted?
Nice.
Oh.
I see that. I saw that live update.
Yeah.
Gosh, I saw it happen too.
Isn't it great?
But did you do that by accident?
Do what by accident?
The updating thing. That was on purpose? It just suddenly happened.
Yeah. It's nice when things sort of work
Just
on the
fall
first
into place.
try. Yeah. Now the only problem is we currently have what's called, it's not a memory leak, but it is a kind of leak. Every time you refresh, you're creating a new WebSocket, right? But on the server side, we're not handling the case where the socket goes away. Does that make sense? So let me show you
Like the condition of refreshing the page shouldn't create another instance of what's happening here.
It's okay to create another one as long as you remove the old one.
Oh, okay.
Right? The problem right now is I put the to-do here because this is creating a leak. If I refresh right now, it's going to create a new event, add it to our event list, but the event is not necessary. So what we need to do is, I'm not sure, what we basically need to do is if the WebSocket gets disconnected, we need to break out of this loop and do this fix. So we're running late. So what we're going to do is we're going to finish this last bit of code, commit it, and then that's it for the lobby. Oh, hi, Mom. And then next time we'll do Quokka JavaScript Bootcamp. Sound good? I think it was worth going slowly through this because it's very interesting to actually build stuff like this.
It is dynamic.
Dynamic. Yeah. So let's finish. Let's just do this last to do, and we'll call it a day. And what I'm gonna do is I have a really cool video from the Fireship IO guy, the same one whose face is in our video game.
Oh,
Okay.
yeah.
He recently did a really cool 10-minute crash course into JavaScript. I'm basically going to do that same crash course with you, so it'll be useful for you guys to just watch the 10-minute video first to understand where I'm going to be going. But because you guys are mostly beginner, like you need more exposure to really internalize what is covered in that one video. And so what I want to do is let you guys go over the video, and then I will go over the same topics in the video, but we're going to do it at a pace where you can ask questions and I can answer them, and we'll solve interesting problems. We're going to solve some interesting problems with it as well. Okay, sorry. We're getting distracted from our goal here. We need to detect when the WebSocket is closed. So let's look that up. So this is Fast API.
So the WebSocket closes?
Yes, when you refresh your page. Oh, I should show you that. So
Yeah,
check
show
it.
the diagram.
Hmm?
I thought you were going to use a diagram.
I wish I don't know if I can. But basically, there's the WebSocket is like think of it like a connection, right? Like an old school connection. Like let's say you connect your VC, like you connect your TV to something, right? There are various life cycles associated with that. Yeah, one sec. Yeah, I just needed to talk to my Google, turn the lights on.
Oh.
Okay, so yeah, so there's various life cycles associated with what we're doing. So take a look at the code that we wrote here. WS WebSocket on message do this, on close do this, right? So in JavaScript, we're able to say create a connection. Every time we get a message, do this function. When the WebSocket closes, do this. So we get a notification about each of these. In one case, we have the event that the socket got closed. In another, we get the message that a message is available for us, right? This is client side, though. This is going to run in the browser. We need the same thing, but on the server, right? We need to be able to say, is the WebSocket closed? And if so, then remove the event from the game, because that's the gist of what we're trying to make, right? So Fast API WebSocket check if closed, or if connected. Yeah, that's basically it. WebSockets is closed. When a WebSocket connection is closed, the await WebSocket receive text will raise a WebSocket disconnect exception, which you can then catch and handle, like in this example. Connection manager, WebSocket accept. Aha. So here's how they're doing it. They make a connection. While true, do a bunch of stuff, and then if the thingy disconnects, then we can remove the event. You got me?
I got you.
So we just need to do what they just copy paste some code. Do you want to write? Rich, your turn.
Let's do it.
So what we're doing is we're gonna wrap the while true with a try block. Yeah, I need to teach you guys about exceptions as well. That's a thing.
So wrapping the while true.
Exceptions seem explanatory. Self-explanatory.
Yeah? Okay.
Like you have a rule and then there are exceptions to the rule, I'm assuming.
Are we using this WebSocket disconnect?
Yeah. let me help you by giving you everything in a comment.
Ooh.
That way you can copy paste stuff. There you go.
Okay. So this whole section's going in the exception.
So here, what we're doing is we're taking our while true loop. This is our while true loop, and it looks very similar to their while true loop. And we're basically putting in the try block and the except block.
While block, the except block. Okay. So the while block is already there. Right? Like the while block is already...
Yep.
We've already done the while block.
Exactly. So we just need to put a try here.
Oh, okay, I see.
Yep. And then this guy needs to be indented. Beautiful. Yep, one more indent. Okay.
Disconnect. Oh, it doesn't find it.
I think it's because I'll paste for you. It's because of reasons.
Oh, there's other...
The top of it.
I imported it for you, so you're good.
Okay. So I get disconnect. Okay. Comma.
Mm-hmm.
As so the exact same thing here, manager.
Nope. We're gonna do a different thing. So, so when the WebSocket disconnect occurs, that's when we need to remove the event from our game. So we did this thing on line 98 where we added the event to a set of events. We now need to remove that event from the set of events. So you say game dot events dot remove parentheses event. That's it. That should do the trick. No semicolons in Python. We don't do that.
Oh.
We don't do that here.
Okay.
We don't?
We
No
don't.
Oh my god.
Oh my god. Oh my god.
Oh my god.
Well, it makes the new line then ever more important.
Yeah, evermore.
So to verify that this is working, what I want to do is put a little print statement right here at the end. Print game.events. Okay? So what this is going to do is every time a WebSocket closes, we will see the state of the events list. So we can check to see is there 2 things in there? Is there 1 thing in there? Is there 3 things in there when the person disconnects? Make sense? Okay. So let's give this a try then, yeah? Let's go back. I'm going to create a new... I'm going to host a new game. Uh-oh. Create game. Uh-oh. Uh-oh. Wait, why doesn't it work anymore?
Oh no. It was Rich. He did it.
No.
I saw you do it.
Oh, this is weird. I'm not seeing any errors or anything. Why why isn't it working? Shad, create. Wait, what's going on here? It's not working. Why does it stop working?
No, our button.
This is weird. It's not working and it's not giving us an error. But we didn't change this code. What happened here? Hold on. Let me try restarting everything. Oh. Oh. Interesting. Oh. Look what just happened here, you guys. Oh.
What is it?
I don't know. Something very strange is happening.
Wait, what are all those?
Interesting. Wow.
Is it glitching?
Yes, it's glitching. It's glitching hard.
That's so crazy.
All right. Let's try again. Create. Okay. I think I know what happened. But maybe I don't know what happened.
What's your hypothesis?
It's only an inkling at best at this point. Hold on. Okay, so here I am connected. If I refresh the page, I should see a printout from line 113. It should print the list of games. So let's try. Refresh. There it is. Wait. Wait, no. Oh, I'm not seeing a disconnect. Hold on. I need something to tell me that stuff has happened. Hold on. This was not helpful. We needed more information here. We needed to say WebSocket disconnect followed by the game events. Restart. Refresh. Shad. Create game. Refresh. Okay. Hold on, let me try closing the page. Okay. It's not disconnecting. Interesting. I kind of expected it to disconnect. There's a third connection. Do you see all the connections happening? 1, 2, 3. We now have 3 connections. You know what we should do? Let's put a couple more print statements. So here is a WebSocket accept. WebSocket connected. WebSocket disconnected. And let's put them. So now when we add an event, we can see the game events after we connect. And then here we disconnect. Event's gone. Let's restart. And let's create a game. Okay, so I'm seeing a lot more information now. So there it says WebSocket connected here. And then we see the list of connections. But it's not disconnecting when we refresh the page. Why is that? It's okay. I'll do some research offline to figure out why we're not getting the disconnect. The bit about what you needed to understand is all here, right? For whatever reason, refreshing the page doesn't trigger a disconnect event, which it should. So I'll have to check that out. But like if I refresh the page, you can see that I got another WebSocket connect event, but I didn't get a disconnect event, right? So the old one is still there. And if we look at the list right here, after the WebSocket connected, you can see there's two elements there. Here's one event object, here's a second event object. So there's two event objects, even though there should only be one. And that's because we didn't get the disconnect event to remove it. Make sense?
Mhm.
Yeah, I'll figure it out though. It's probably something simple, no big deal. We'll fix that. All right, I think that's it for today. Did you have fun?
Yeah, loads of fun.
Yeah. We made some good progress. This is our last episode on the game lobby. Game lobby. We're going to do, next time we're going to do our first session on JavaScript. Let me show you the tutorial that I want you to watch on your own time.
Okay.
And then when we get together next time, I want to go over basically we're going to cover half of what that guy, what Jeff talks about in his video. We're going to cover half of it, up to the part about classes. So JavaScript crash course, Firebase. No, not Firebase. Fireship.
That weird JavaScript course.
Fireship.io. He has such great videos, I have to say.
Okay, I'll subscribe to him.
Sure.
Good old Jeff.
Good old Jeff. Search. JavaScript. Hold on. I should have written it down when I saw it. Hold on. Let's go to my video history. Actually, I don't want all of the internets to see my history. So I'm going to end the stream here. Bye, internets.
Bye, man.